All right, we're on to now 4 terms. Okay, again, remember our terms are separated by an addition sign or a subtraction sign. So we've got 1 term, 2 terms, 3 terms, 4 terms. Now, I think these are probably one of the easiest polynomials to factor. So when we factor using 4 terms, we do it by the method we call factor by grouping. Basically, you're just going to take the first 2. We're going to kind of do it 2 at a time, because we know how to factor binomials. So these, we're just going to factor out the greatest common factor. What is the greatest common factor between x to the third and x to the second? Well, it is just x to the second right there. And then you're left with x to the second times x will give you that x to the third, and x to the second times -1 will give you that negative x squared. Okay, do the same thing with your second grouping. Okay, we're just going to factor out a 9. I'm going to be even more specific and factor out a positive 9. Okay, sometimes we'll show you over here how you could factor out negatives, but we're going to factor out a positive 9. Now 9 times x will give me this 9x, and 9 times -1 will give me that -9. Just kind of check that that factors back to this, and this, distributes back to this, and this distributes back to this. Now, this is all nice, but it doesn't really look that much nicer and neater than this. And remember, when we're factoring, we want just multiplication. We don't want that add in the middle of our parentheses right here. So there's another way to write this. Okay, so if it looks like this, if you've got the same binomial right there, you can actually write this as 2 binomials. Okay, so I always, for some reason, put that binomial that's common, I put it in the last right there. And then over here, I got this x squared plus 9. Now, the reason that I write it like this, look, notice that x squared just comes from my first, what I factored out of the first grouping. My 9 comes from what I factored out of that second grouping. But remember, when you distribute this, when we check this x squared multiplies to both terms. So x squared times x minus 1, that's basically just exactly what you have right there. And then this 9 factors to both, or distributes to both. So that's what you have right like that. So if you check this, you got your x squared times x, that'll give you your x to the third. X squared times -1, there's your negative x squared. 9 times x, and 9 times -1 will give you that -9. Okay, this one was really close to having to keep going, so double check it. This was a plus, though. If this were a subtract, you would want to keep going with that. Remember, you've got a difference of squares, but that's a sum of squares. You cannot factor that anymore, so go ahead and circle that. All right, let's look at this one over here. Same thing, I just kind of cut it right in half right there, and let's factor out our greatest common factor. So it's still just a k squared here. K squared times k will give me that k to the third. K squared times 5 right there will give me that 5k squared. Now on this one, notice I want my second binomial, I want it to be the same thing. So right here, this looks very close to k plus 5, just your 2 signs are different. So in this one, I'm going to factor out a -1 right there. And then I could say, well, -1 times a positive k gives me that negative k. -1 times a positive 5 will give me that -5 right there. Okay, so now I've got the same binomial right there. I can just rewrite this. Oops, I'm going to need, let's do this. We're going to rewrite it over here. This one is one we're going to have to keep going with. So we're going to rewrite it as our 2 binomials right here. We're going to have that k plus 5 as one of our binomials, and then you just look at what's in front of the other term. So you've got a k squared and then a -1. Okay, again, whenever you see a square, just check to see if you cannot go any farther than that. In this case, we've got a difference of squares, so you can go ahead and factor this into our conjugates. You've got a plus and a minus. Take the square root of the first, so that's going to be a k. Square root of the second, just a 1 right there. And then this k plus 5 is also going to be come down with us, and that is that lovely 4-term polynomial factors into 3 binomials right there. All right, let's try this one. Let's try a nice orange. Again, we're just going to cut it in half. 4 and 5 don't share any common factors, but they both have some v's. So let's factor out a v squared, and I'm left with 4v minus 5. And then again, I want my first term to be a positive 4, so I'm going to factor out a negative 4. And then I've got a 4v minus 5. Negative times a negative will give me that positive 20. Okay. All right, let's rewrite this. So we're going to rewrite this as binomials. So I've got a v squared minus 4 in 1. And notice these are the same thing. So that 4v minus 5 can just go in that second binomial. All right, what do you notice? Correct. We've got a difference of squares. So you're going to factor this into our conjugates, plus and a minus. So v goes in my first place. 2 squared is 4, so 2 will go there. And then this is also going to be this 4v minus 5. And there is that one done. All right, last example here. I should have given you some more room on these, I guess. Let's look at this one. So again, just kind of cut it in half, and we're going to factor out our greatest common factor. So in this one, I could factor out a 2. 2 goes into both 2 and 18. I can also factor out an x to the 4th. So 2x to the 4th, and then I'm left with x minus 9 over there. On this one, I've got a 7. Let's factor out a positive 7. And then I've got an x minus 9. Perfect. And then we can just rewrite this as a grouping of 2 binomials. Got the x minus 9 as one of my binomials. And I've got a 2x to the 4th plus 7. Those are just, remember, the 2 of what I factored out right there. Double check, is this a difference of squares? No. Or a sum of cubes or a difference of cubes? No. So this is actually as far as you can go on that one. And that's how you factor 4-term polynomials.